Hello, everyone. Welcome to another week here, and we're going to finally be finishing off this linear function unit, which is kind of nice. And we're really going to have two new lessons this week, and then that quiz on Friday. If you've had a chance to look at that schedule that I posted kind of late last night. Okay, so we're looking at how to graph linear functions in this lesson, and also touching on XY intercepts. This won't be divided into a bunch of separate videos here. I should be able to get through all of this in a relatively okay time that doesn't waste your own time and lets you leave room for the rest of your classes. So let's dig in. So the first thing we're going to look at is how to graph linear functions. Because we've seen how to define a linear function, we've seen the differences between what a linear function and what a linear relation might look like, stuff like that, right? So now we're actually going into the how-to of graphing all this stuff. So let's recall from around like one of the very first notes that we took. We were talking about the definition of a function, and we said that a function is some kind of relation which has one output of y for every x input that we put in. So our x, if we put in 4 on our x, we'll get some output y, let's say 11. And we put in 2, we get maybe a 10. But it would never be the case, or it's not a function, if we plug in a 2 for our x and we get out maybe a 6 and an 11 for our y. That breaks the idea of a function. So recall, we had this little picture here too. We plug in some we can say x coordinate into our function machine. Our machine runs the function on it, whatever that function looks like. And this is what we're actually going to demystify today, what this function is. And out we get some unique y coordinate just for that function. So one x coordinate and one y coordinate we get out of. So how about we actually give a name to whatever that function is? I'm just going to copy and paste this down here. This will be our first example. I'm going to do a little erasing down here. And let's, instead of just calling that function, let's see if we can give it a name. So I'm going to let's do example 1. And let's say that we want to graph the function y equals 2x plus 1. Okay. So from that last lecture, or 2 lectures ago maybe, we tell that this is a true and indeed a linear function because none of our variables here are in denominators, and our x variable, or actually this whole equation has a total degree of 1, right? Because both of these terms, the y has a degree of 1, and the 2x there, that term has a degree of 1. So the highest degree there is 1. We have a linear function. So now what we're going to do, we're going to figure out how we can actually go about graphing this. So what we're going to do, I'm going to take this example that we had above here with that function machine, and now instead of writing function in the middle, we can actually give it a more exact answer, which is always what we want to do. You want to take something new than when we're learning it, take it from a general idea and put it into a more exact feel, especially in math. So what we can say, well, what we're plugging this x into and we're getting y out of, we're plugging it into this function y equals 2x plus 1. And so essentially what we can do, let's set up a table. Oh, happy table down here. The table of values with these are going to be your best friend. And on our left side, we'll put our x. On our right side, we'll put our y. And so recall that this is our input side over here, and our y is our output. So what we can do, we can ask ourselves, let's just plug in a bunch of inputs here for x. Let's put in a bunch of different inputs here for x, and we'll see what y outputs we get for this. So it doesn't matter which values you choose when you do this. So for me, I'm going to choose 4, just because I think 4 is an okay number. And I'm going to put some in the negatives, and I'll put some in the positives. It's usually good to do a mix of both negative inputs and positive inputs. So maybe let's do -2, -1, 0, 1, 2. And when you're putting these in, it's usually good to keep them scaled by the same amount. So here I'm increasing by 1 each time. +1, +1. You don't have to do 1, you can do 2. So I could have done -2, 0, 2, 4, 6, that whole thing. But it's usually good to keep it increasing at the same amount. And so for the output, well, what we need to do to figure this out is let's look at this -2 here first. Let's look at that -2. Essentially, we're taking the -2, that's going to be our x that we plug in. So -2 pops in here. And actually here, let's do this as a different color. So let's say that we plug in -2. And then down here, so we feed it into our machine. And then it's going to turn into this. So it's going to become y equals, and then wherever we see an x, we're going to plug in that -2 because that's what we're inputting. We're inputting for the place of x. And we solve for this. So what we have here is y equals, well, what's 2 times negative 2? That's negative 4. Negative 4 plus 1. What's negative 4 plus 1? That's going to be our output. So negative 4 plus 1 is negative 3, right? And that's what our y is. So if we plug in a negative 2 right here, we get out a negative 3. So let's write that in. And we can do this for the rest of them, right? We can keep going here. So I'm going to take it out of this, and let's pretend that we're doing y equals, and actually, let's just do this. So we have y equals negative 1, 2 times negative 1, okay, plus 1. Well, that's just going to equal y equals 2 times negative 1 is negative 2 plus 1. That equals negative 1. And it turns out if you did this for the rest of them, you would see that we're going to slowly increase in our y by negative 2. So we have negative 3 here, negative 1. And the next one would be positive 1. The next one would be 3. And the next one would be, what would be after that? 5. I don't know why this would be so long. So now that we have this, now that we have our table of values here, we can actually start graphing. So what I'm going to pull in a little graph. Go to our stickies, we'll do our grid, paper, make it the smaller grid, and then we're just going to pull this down here. Let's make a nice graph. We'll put it right over here. And what I'm going to do, zoom in on our graph here. I'm going to make my axes first. That's a good straight line, Mr. Carroll. Nice job. Oh my gosh. So this is our y. Let's do next there. This is next. Okay, let's see what we can draw here. So use my blue as I normally do. And let's look at our first coordinate. We have a pair of negative 2 on the x and then a negative 3 on the y. So let's count over negative 2 on our x. 1, 2. And when we had a negative 2 here, our x mapped to a negative 3 on our y. So we will count down to 1, 2, 3. And there's our first point. We go up to negative 1, negative 1, negative 1, negative 1. We go 0, 1. So 0 and 1. 1, 3, and then 2, 5. 1, 3, and then 2, 5. And you see, yeah, this does indeed looks like it's a linear function, right? And when we're drawing these, please to make sure to draw a line through it. Because if we don't, if we just leave it as those dots, it's not a continuous function, right? It's not a linear continuous function. It's just a discrete continuous function. And whenever we have something that's written in this form, this is an example of a continuous function. So we need to make sure that that line is drawn to show that it's a continuous function. So this is continuous. Always draw your line. Always draw your line. And so an example of the question I could give with this is graph this function and then tell me its domain and range. So that'd be some in interval notation or in set notation, whatever you wanted to do there. So there's just one example of that. Let's do another example just to make sure that we're clear on everything that's going on here. So I'm just going to copy this. We're going to paste it down here. And what do I need here? Let's do our red. Do example 2. And let's look at this question right here. We got y equals negative 1 over 4, x plus 2. Okay. So same thing, we're going to be setting up, I'm going to go through this one a bit quicker. We're going to be setting up our table of values. And we got our x, we got our y. I'm just going to erase everything that I had on this one here. Can I get that? Come on. Oh, we got it. Let's see if I can get those ticks out too. Look at that. Beautiful. All right, so same thing. I'm just going to pick a random set of x values. Let's just say I'm going to take it easy. I'm just going to go 0, 1, 2, 3. And what I'm going to do, I'm going to plug those x values in as inputs into our x up here. Let's see what we get. Hopefully my pen isn't dying. That would suck. Okay, so I'm just going to show the main bulk of that work down here. So let's say that x equals 0. Okay, so let's do that one first. We're going to have y equals negative 1/4 times 0 plus 2. Well, that's going to equal negative anything times 0, which is 0, so we're just left with 2. Okay, let's do x equals 1. So that's y equals -1/4 times 1 plus 2. -1/4 times 1, well, that's just -1/4, right? Plus 2. Now this, you could switch everything to a common denominator, so I'll do that. So we have 4 as the common denominator, so that means I have to multiply everything on the right-hand side, or on this on that 2 there, by 4. So we get -1/4 plus 2 times 4 is 8/4. -1 plus 8 is 7/4. So 7/4 4. We can actually convert that. Let's convert that to a decimal, just because it'll be easier to deal with on our graph. 7 divided by 4. We can just plug back into a calculator and you get 1.75. I'm sure some of you could have done that in your head as well. And I'm just going to go, I'm actually just going to go do 2, because just for the sake of time here. Let's do another work here. And we have x equal, oh no, my pen's dying. X equal to, what is it, 2. And we do y equals, what do we need? -1/4 times what? 2 plus 2. So here's where we can do a little bit of a trick, because we see that we zoom in here, we have a 2 in our numerator and we have a 4 in the denominator. We can basically cross cancel those and ask ourselves, how many times does 4 go into, or how many times does 2 go into 2? Well, it just goes in there once. How many times does it go into 4? It goes into it twice. So we're left with -1/2 plus 2. -1/2 plus 2, we can think that, well, that's just going to be 1.5. We're just taking away 0.5 from 2. So 1.5. We go up on our graph here and we graph each of these points. And what we're going to do is 0, 2. So it's point 0 and 2. Plot that. We got 1 and 1 3/4. 1 1 and 3/4. So we're going to be about there, just like almost at the top. And then 2, and we're at 1.5. Oops, I did not do that right. Silly me. 1 and 3/4. There we go. And then 2, we're at about 1.5. This is very approximated, so I'm just going to draw a line through all those there. Forgive me if this is not super accurate. That's going to be hard. All right, take that as it is. My iPad's snapping automatically to points, so it's not really helping. But what I'll do is draw my arrows to show it's continuous. And one step further, I should have done this on the other one. Draw a curved arrow or a curved line away from your graph, and we're going to label it whatever that function was called. So we saw that the function was called this, y equals -1/4 x plus 2. Let's do that. Y equals -1/4 x plus 2. And we should do that with the one up here as well. So this one's actually called y equals 2x plus 1. It's fair enough to say, right? Cool. And that's all that is. That's fully graphed now. That is fully graphed. We're going to do another example. I'm going to double check my time here. What are we at? Okay, this might be a bit of a longer one than I anticipated. That's okay. All right, let's figure out how we can find the x and y intercepts of a graph. Finding x and y intercepts. Okay. So let's define what these are. So the x-intercept, you might be able to guess what this is. It's the point at which our linear function crosses the x-axis. Point at which our linear function crosses the x-axis. And y-intercept, well, if you don't know, then I'm sure you know now. I'm going to copy and paste this whole thing because it's going to be the same wording, except instead of y, we're going to do, or instead of x, we're going to do the y-axis. And let's actually, I'm going to ask you this. You can pause the video to ask yourself this question. When would the x-intercept occur? If we look back at our function machine up here, when would that x-intercept occur? When would it occur? So think about it. If we plug in, or even if we look on the graph here, when would an x-intercept occur? At what y value would an x-intercept occur? Well, we see that this one has an x-intercept right here. What's the value of y at this point when it's crossing through? Well, the value of y is 0, right? We're at a 0 value of y. So to find this, we set y equal to 0 in our function. Oh man, my pencil's really having a hard time. I can see the actual exposed metal underneath now, which is freak. I didn't know I had exposed metal, which sucks though. It's like $100 for a place. All right, sorry, that's my rant for the day. Okay, and to figure out the y-intercept, well, when does y equal 0? Y equals 0. Or sorry, when does the line cross the y-axis? When does this line cross this axis here? Well, you see it's crossing it when x is 0. When x is 0. So we set x equal to 0 in our function, right? So let's look at an example of how we can do this. Let's say, what do we have? Example 3, right? Just make sure I'm consistent. Come on. Example 3. Okay. Let's say that we were told to find the x and y. Intercepts and graph. Okay. Find the x and y intercepts and graph. Well, what we can do, actually, let's just do find the x and y intercepts right now. So let's say that we were given the function 3x minus 4y equals 12. Okay. How do we figure out what the x and y intercepts are? Well, let's start with x. So if we look at our find the x-intercept, we said that we need to set y equal to 0 because that's when our line is going to cross through the x-axis, and then we're going to solve our function. So big thing, whenever you see a function like this, you don't have to write it like this. This left-hand side can be put on this side, and the 12 can be put on this side interchangeably. These are the exact same thing. If you ever need to rearrange for whatever reason, this is the same as this. Okay, they're all the same. Sometimes people have trouble just seeing that similarity. Just want to make sure that that's out in the open there. Those two are the exact same thing. I'm going to stick with this side though for the time being. So I'm just going to erase that just to remove any confusion. Okay, so we need to set y equal to 0, right? So let's do that. So whenever I sub something in, and I was doing this above here too, right? You see, whenever I subbed in those x values, I would always put them in brackets. I'm going to do the same thing here. I always recommend you do this. Bracket, close bracket, 12. 3x, can't do anything with that yet. What's 4 times 0? Anything times 0 is just 0. So we're just left with 3x equals 12. How do we get that 3? How do we get this 3 out of here so we can get x on its own? Well, right now, x is being multiplied by 3. So we need to do the opposite, which is divide by 3 on both sides so that everything stays equal. And we find that x equals 4. Okay, let's do so this is the x-intercept. And let's do the y-intercept. Okay, what do we need? Okay, so with our y, we're going to set our x equal to 0. So this is going to be 3 times 0. Oh, see those gaps popping in? It's annoying. 4y equals 12. Okay. 3 times 0, that's just 0. So all we're left with is negative 4y. Don't forget that negative sign. It's having a happy time right beside the 4. And same thing, and that negative 4 is being multiplied by the y. So we need to do the opposite. We need to divide it. And our y, 12 divided by negative 4 is negative 3. So when we're writing this out, what we can say that the x-intercept occurs at x equals 4, or at, we can write this in coordinates, 4 dot 0, right? I'll put a little therefore. Therefore, the y-intercept, and I want you to communicate it like this, occurs at y equals negative 3 or 0, negative 3. Okay. So two very basic ways to figure out what the x and y intercepts are. So that's boom, boom. Those two are done. And what I want to do for the final part here is to graph how to graph a function from the x and y intercepts. So we just have one more example to do here. So graph function from x, y intercepts. Okay. So this is using a combination of this technique above here of finding x, y intercepts and of doing our input and output of the one above. So an example, a question could be, what do we have? Example 4. Okay. Graph following not relation. Well, we could say relation, but let's be more specific. Graph the following function using only x, y intercepts. Okay, graph the following function with x, y intercepts in our function. Let's say that our function is y equals -2 over 5 x plus 2. Okay, first step, find x and y intercepts. So we need those before we can even do any graphing, right? We can't just go in blind graphing. We don't know what's going on. So let's do our x-intercept first. Let's do our x-intercept first. Okay. So we're going to start with sub in y equals 0, right? So to do that, we're going to do it's the same kind of format before. So now we have our y is kind of isolated already. So we actually have 0. We'll follow the same common theme here. I'm going to put brackets around anything that I substitute in. Equals -2 over 5 x plus 2. Now that we're at this part, we need to work on getting x on its own. So we're going to go back to my low-hanging fruit analogy. What is the easiest thing in this equation that we can move right now? What is the easiest thing that we can move? Well, we can get this +2 onto the other side, right? Because we want to get x on its own. Right now, this +2 is hanging out over on this side. So let's just move it over here. How do we do that? It's being added. We got to subtract it. So we'll do a -2. We'll do a -2 over here. We get -2 equals -2 over 5 x. Okay. So we're getting there. But now what's the next easiest thing to move? You might be saying, well, let's get rid of that 2. And you could do that for sure. But I would say, let's do this 5 first, because it might make our lives a little bit easier here, okay? And the way that we're going to do this, well, we see that the 5, it's in the denominator of our fraction here, which means it's being divided. So if it's being divided, we need to do the opposite. We need to multiply everything on this side by 5. By 5. And our cross multiplication means that our 5s are going to cancel. And we're going to be left with, well, what's 5 times -2? That's -10 equals -2x. We're almost done. We need to get that -2 out of here, right? How do we do that? It's being multiplied right now, so we got to divide it. And we're left with 5 equals x. Or the way I prefer to write it is left to right with our variable. X equals +5. Okay. Let's split this down the middle. Let's do y-intercept. Sub in x equals 0. So let's do this. We have y equals -2 over 5 times 0 plus 2. Plugging in that 0 there. -2 over 5 times 0. Hey, that's just 0. It's kind of nice. Y equals 2. We're done with that one, eh? See how nice that is? So what this means is that our x-intercept is at 5, 0. And our y-intercept is at 0, 2. So let's bring in a graph. I'm going to be lazy. I'm going to copy and paste one that I already had. Copy. Let's see. Oh, I could fit it in right there. Beautiful. Let's erase everything that we had on that past one. And we're just going to plot those 2 points. So we had 5 and 0. So let's do the 5, 0 one, our x-intercept first. We have +1, 2, 3, 4, 5. And over here we had 0, 2. So 0 and then +2. 0, 1, 2. And we just have to connect those 2 points. And we're off to the races. Ooh, that was bad. Oh, that was so bad. Come on, Mr. Carroll. Ugh. This isn't. You bear with me. I'll get this. You know what that'll do for now? It won't be perfect, but you get the gist. You'll be able to draw a better line than me. It's hard because my iPad keeps snapping to points. So remember to label this line. So we know that this line is called, what was the function called? Y equals -2 over 5. -2 over 5 x plus 2, right? And that's our function. That's how you do it from just x and y intercepts. And that is the end of this lesson. So I will post the practice problems with this. You likely will have to print it out this week. I know some of you are very keen on how to use Google Docs, and I really don't know how you do it. Michelle's like a wizard at it, so keep doing what you're doing with that. And yeah, we will reconnect on Thursday. And Friday we do have that kind of quiz. up to everything that we're learning today. So it won't include the lesson on Thursday. Okay. That's it, everyone. I hope your weekend was amazing. I hope that your other classes are going very, very well. And I will see you later. Okay. Take care, everyone. Ooh, let's check it off.